Let's look at a carbon that is double bound to other atoms. So, let's just look at a carbon double bound to another carbon. Let's put some hydrogens on there. Okay, so what about this carbon? Right? What's the hybridization of that carbon? Now, technically, that carbon still has 4 bonds. So I think in my last video, I talked about carbon having 4 bonds. Well, I really probably shouldn't use the word bonds because it's not necessarily about the number of bonds, right? Because technically this carbon has 4 bonds, but really when we go over how to identify hybridization, which will be in like the next couple videos, I will talk about electron groups. That's how I like to define this. And we'll go over how do you identify an sp3 hybridized carbon, or an sp2 hybridized atom, or an sp hybridized nitrogen, or all those things. And we'll go over that. Okay, so don't worry about that right now. But what happens if we take, for example, we want a carbon that is going to be sp2 hybridized. And I know I haven't told you how to identify that yet, but we will do that in the next few videos. What does the hybridization look like? Well, what it looks like is exactly how it's described, right? It's the same process. Okay, if this carbon is sp2 hybridized, that means that I took an s orbital and 2 p orbitals. So let's just say I took the px and the py, right? And then here's the pz, okay? So I'm going to take the s, the px, and the py, and I'm going to take all of these little guys, these orbitals, these 3 orbitals, and I'm going to hybridize them together. But remember the most important thing that I said you have to remember for this video, which is the number of orbitals you put into hybridization equals, and this is where you say, the number of orbitals we get out. So if I put 3 orbitals into hybridization, I'm going to get how many orbitals out? Yes, 3 orbitals out. So I will get 3 degenerative, in other words, identical, sp2 orbitals, right? So here's the first one, here's the second one, here's the third one, okay? Now, what's interesting is look at this pz orbital I've got over here. Did I touch that orbital at all? Did I hybridize it? Did I do anything with it? No, I didn't do anything with that p orbital. So guess what? It's still there, and it's still exactly how it was originally because I never hybridized it. So we still have that pz orbital, okay? So that means that if I start my process with an s, a px, a py, a pz, and I hybridize the first 3, I will end up with 3 orbitals, 3 hybrid orbitals, an sp2, an sp2, an sp2, and I will still have that 1 p orbital left. So, how do these arrange around the nucleus? All right, so again, you're probably going to want to go to the Googles and look up on the internet images of an sp2 hybridized atom, with the orbitals to see it better in 3D because these are not very good pictures. But let me do the color coding thing that we did earlier. So let's say that this is our pink sp2 hybrid orbital. So that's that little guy. Wow, that's pretty bad drawing, but okay. And then I'll do a yellow one. All right, so here's the yellow one. And then I'll do a green one. All right, but what about that p orbital? Oh, before I jump to that, the important thing to know is that these three hybrid orbitals are all existing in the same plane. They're called trigonal planar, okay? So notice how this kind of looks like a triangle. See that? Oops, that didn't work out the way I wanted to. Let's draw this. Here's a triangle, okay? And those three hybrid orbitals are actually all flat on the plane of your computer screen or piece of paper or your tablet or whatever you're looking at this from. Now it's this p orbital here, and I'm going to make this p orbital purple. So, and I'm going to actually color it in. Okay? So this p orbital is actually going to be going perpendicular to the plane that we have with our hybrid orbitals. So if I'm looking down at this picture and I'm looking down at this flat plane, my p orbital is actually going to be coming directly out at my face and directly behind the plane. Okay, so really this round ball here is supposed to represent the top part of the p orbital because our eyeballs are kind of looking directly down that p orbital. And so that's where the node of the p orbital would be in the node of this plane, this trigonal plane. So again, looking up images online will probably help you visualize this a little bit better. Now for this molecule, we would say the central atom that's at the center, at the node of this, we would say it is sp2 hybridized atom, and we would also say that it has 33% S character. So for example, if this was a carbon, like we have right here, if this was a carbon that's sp2 hybridized, we would say, oh, this carbon's sp2 hybridized, which means it has 33% S character. How do we know that? Well, we know that because for its hybrid orbitals, well, I guess I should say its hybrid orbitals have 33% S character because they were made up of a component where the S component makes up 1/3 of their total characteristics, of their total orbitals used. So sp2 hybrid orbitals have 33% S character. Okay, and lastly, what if I don't want to hybridize all 4 orbitals, and I don't want to hybridize 3 orbitals, but what if I only want to hybridize an s orbital and a p orbital? Okay, so let's call this the px, and we'll call this the py, but it really doesn't matter because remember, px, py, and pz, they're all the same energy-wise. The only difference is their orientation in space. So it doesn't really matter too much. So if I take the s orbital and the px orbital and I hybridize them, right, that means I put 2 orbitals in, which means how many orbitals am I going to get out? 2, exactly. 2 orbitals out. Right, so 2 hybrid orbitals out. And, you know, again, we're going to use the same naming scheme, which is we will name these after the orbitals that we use to hybridize and create them. And since we used one s and one p, we call these sp hybrid orbitals. So we will end up with 2 different but identical sp hybrid orbitals. And we will also have the py that we never touched, as well as the pz that we didn't touch. Now again, the way that these look all together is really hard to draw in the software that we had. So here, we actually are only showing you the orientation of the 2 hybrid orbitals.